Hello, today I will be explaining how to draw the Lewis and VSEPR diagrams for xenon dioxide difluoride. So to start off, we need to find the electrons and the pairs so we could be able to draw the Lewis diagram. So we'll start off right here. So xenon has 8 valence electrons. So we're going to add that to the 2, and oxygen has 6 valence electrons. And then we're going to also add the valence electrons of fluoride, with times 2, of course, because there's 2 of them. And this will equal to 34 electrons total, which in half would give us 17 pairs for the valence electron pairs. So here we have the Lewis dot structure. So with Lewis, and we kind of get and we could see the pairs, the electron pairs, but we can't see the shape of the actual molecule. So to be able to see the shape of the molecule, we could use the VSEPR, which is seen here. Now with the VSEPR, we have 4 bonding pairs, which is with the elements of oxygen, the fluoride, and the other oxygen. And we have 1 lone pair. Now, with the repulsion theory, we can see that that there is repulsion, and which is going to affect the angles. So the angles right here will be less than 90, and over here it would be less than 120. And also with the VSEPR, we can also better draw out the shape. So when we have this like triangle, it's actually when it's coming out. So as we can see over here in this diagram, or of the 3D diagram, we can see how it's coming out of the plane, while the ones with the straight lines would be in the same plane as we can see here, while with the dashes it would be the one furthest away from us in the back. And over here we can see the lone pair that's repulsing due to the lone pair bonding pair, and then which is stronger than the bonding pair to bonding pair. And so once again, this was the Lewis, and this was the VSEPR. Now I'm going to be explaining how to draw the Lewis and VSEPR structures for tellurium, pentafluoride, anion. So it's right here. And we're going to take the valence electrons of tellurium, which is 6, plus 5 of the fluorides, and fluoride has 7 valence electrons, and then plus 1 for the anion, since it's an anion, which will give us a total of 42 electrons. We take half of it, so we break it off into pairs, which will give us 21 pairs. And now we're able to come up with the Lewis dot structure. So here's the Lewis dot structure. Of course, when you're drawing out the Lewis dot structure, you have to make sure that you have the 21 pairs that you came up with. And but once again, the Lewis dot structure does not show you the actual shape. So to better see the shape, we'll use the VSEPR. And here we can see that of course the triangles here, there's two, which means that the fluorides are in a different plane than the fluoride here that's straight up. And we can better see it on the top diagram here, the 3D diagram. So these two are coming out towards you, which are going to be the triangles, while the dashes are the fluorides in the back, moving away from you. Then we have the lone pair down here, also seen up here, which of course is still going to cause some repulsion, and which will give us an angle of less than 90 for every angle in this VSEPR diagram. And here we also have a 3D model, which further shows how it's not a 2D figure, how we get with the Lewis. So, but also with this 3D model, it doesn't show the repulsion as the one over here. And that's it.